Okay, so we're going to continue with this problem, and as soon as we're done with this, we can go do our pear deck. Okay, so the next method is the move x and divide by the number with y. So this is the one that I like to say, move the x to the other side, and you do opposite operation. Okay, so once you move it from the left, you are left with 2y equals 6 minus 3x, and then you divide by the number with y. So I'm going to divide by 2. Divide everything by 2. So I am left with y is equal to, remember you have to divide everything by 2. So it's 6 divided by 2. We get 3. And then if we cannot simplify the fraction, we can just leave it like that. So minus 3 over 2x. I'd go graph this one. It's just going to be a sketch so you can see what, right? So if we graph this one, your intercept is 3. Your slope is negative 3 over 2. So you would go down 3 times. 1, 2, 3. You'd go to the right 2 times. Okay, you notice how your picture looks the same as it did over here when we did the cover-up method. Okay, so you can pick whichever way you like when you're graphing standard. Remember, standard is when x and y are on the left-hand side of your equation, and then a, b, and c just represent numbers. All right, so let's go back to our pear deck. You can put your notes to the side so you can use them. And we'll continue with some examples there. Okay, so slide 3 tells you to graph 2 equations from slope-intercept form. So if you notice, slope-intercept is when you have the slope and the intercept right off the bat. Okay, so I'm going to go ahead and go to student mode so that way you can see what I'm doing. I forgot that I put it on student paste, so I gotta go find the slide. Okay, so it's slide 3. I'm sorry. I'm just gonna go ahead and graph the 2 different equations. Okay, so my intercept, so my slope is here. My intercept is, I'm gonna change the size so that way it's smaller. My intercept is at positive 6. My slope is negative 3 over 2, so that means I'm going to count down 3 times. 1, 2, 3, to the right 2 times. There's my new dot. And I'm just going to repeat it so my line can get longer and longer. So 1, 2, 3, to the right 2, down. Why does it keep doing that? 1, 2, 3, to the right 2. 1, 2, 3, to the right 2. Okay, I'm going to use the line feature. Hopefully connect them with, oh, do not want that. I would resize it every time, guys, just so it's not so thick. Okay, so there's my first line. Now I'm going to go and graph my second line. So my slope is 1/2. My slope is 1/2. My intercept is negative 6. Change that color. Okay, so negative 6 this time. My slope is up 1 to the right 2. So up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Okay, and if you notice, right, I'm going to connect those points. Where my lines intersect, I have one solution, right? The one solution is right here at this point. So what do you notice? I noticed that my lines intersect once. Okay, my lines cross. How many solutions? There's one solution. And then what is the solution? What are the actual coordinates of your solution? So remember it's 6, -3. So my solution is 6, -3. Okay, so moving on to slide 4, this one also tells me graph two equations from slope-intercept. Okay, so then you've got a system. There's two equations. I'm going to go back to student mode so we can graph those together. All right, so I'm going to graph the first one. It's the same equation, right? So I'm going to start at +6. I'm going to go down 3 times to the right 2, and I'm going to keep doing that. One more time. Okay, I'm going to do the next. Actually, I'm going to connect those. Okay, I'm going to do the next one. -3, 2. My slope is +3. Okay, so go down 3 times to the right 2, down 3 times, right 2. Guys, and notice how I'm just putting dots on where I have to move, right? I'm not actually putting the point until I've moved my rise and my run. Okay, so I'm going to connect these. Okay, and if you connect them, right, hopefully you made your second one a little bit straighter than I did. I'm going to do that because I don't like it. It's slanted and it's not supposed to be slanted. So if you need to redo it so that way you can get a better line, then redo it, okay? So let's try to get a little straighter line. Okay, so we're going to answer those questions. What do you notice? This time I noticed that my lines do not cross. How many solutions? None, right? I have no solutions. None. What is the solution? There is no solution. Okay, and some of us may or may not have noticed this, but when we have two lines that do not intersect, right, we have the same slope. When we have the same slope, right, these two slopes are identical. That means that we have parallel lines. When lines do not intersect, we call them parallel. Okay, that is when you have no solution to your system. Okay, so if you move to slide number 5, you're going to graph your two equations this time, but one is in slope-intercept, the other one is in standard. So this is where you will have to do either the cover-up method or the move and divide. Okay, so I'm going to go to student pace so you can follow along. Okay, so on this one, I'm going to graph the first one because it's in slope-intercept. Slope-intercept. So I'm going to graph +3. And I'm going to do my slope, down 3, right 2. Okay, I'm going to make my first line. I don't like that line, so I'm going to redo it. Nope, still don't like that one. Man, why can't I? Nope. Okay, sorry. Third time's a charm. Okay, so now I like to do the cover up because it quickly gives me my X and Y intercept. Okay, so I'm gonna do cover up. I'm gonna cover up the X and I'm gonna solve for Y. That means I am doing divided by 2 on both sides. So X is equal to 3. I'm gonna go put my first point at the 3. Okay, and now I'm gonna do cover up the other direction. So now I'm gonna erase that just so I already figured that one out. So now I'm gonna cover up the other one. I'm gonna cover up Y. I'm gonna divide by 3. So X is equal to, oops, did I do it backwards? Let me redo that. I think I did it backwards. See how easy it is to make a mistake. So I'm going to divide by 2, divide by 2. Y is equal to 3. No wonder it looked weird. So Y is equal to 3. So at Y, I'm going to put a 3. I'm going to put my dot at 3. That's my Y intercept. Okay, so now I'm going to do the other way. Now I'm going to cross out my 2Y, and I'm going to solve for X. So I'm going to divide by 3. So I'm going to divide by 3. So X is equal to 2. So now I'm going to go put dot X equals 2. So if I connect those, notice how this one is a line on top of a line. So I graphed one line and then I graphed the second line and it ended up being right on the same points, right? So this is the one that it's a line on top of a line. How many solutions? There are many, right? There are many solutions for this one. And then what is the solution? There's infinitely many for this. So essentially it would be infinity. Okay, so slide number 6 is for you to practice either using the cover up method or the move and divide, and then you're going to graph it. After that, slide 7, 8, 9, 10, that's it. So starting back at slide 7, you are graphing the system, okay, and you are answering the 3 questions. So slide 8 is the same. Graph the 2 lines, graph your system, answer the 3 questions. Slide 9, graph your 2 lines, answer the 3 questions. Slide 10, you're doing the same. Slide 11 is a challenge. Now you have a picture of the graph with your lines on it. You are trying to come up with or write an equation for each of your lines. Okay? And you can write them in slope-intercept form. The last slide just asks if you are all caught up. Okay, and don't forget that you can use that slope name art as a makeup assignment to replace something that's missing or to add points to something. Let me know if you have any questions. Okay. I will be available on email or Google Classroom. Okay. I hope to see you next class period. Bye, guys.